This lesson is on finding the zeros of a quadratic function from its graph and finding the axis of symmetry. Recall that an x-intercept of a function is a value of x when y equals 0. A zero of a function is an x value that makes the function equal to 0. So a zero of a function is the same as an x-intercept of a function. Since a graph intersects the x-axis at the point or points containing an x-intercept, these intersections are also at the zeros of the function. So this essentially is talking about where the parabola is going to touch the x-axis. A quadratic function may have 1, 2, or no zeros. It would have 1 if the vertex hits the x-axis, 2 if the sides of the upward or downward facing parabola hit, or no zeros if the parabola is floating above or below the x-axis. Find the zeros of the quadratic function from its graph. Check your answer. The zeros appear to be at -1 and 3 when you're looking at the graph. That's where the graph touches the x-axis. To check, you plug in the two numbers, -1 and 3, and see if the equation ends up equaling 0. And it does, so you know that you've chosen your zeros correctly. Find the zeros of the quadratic function from its graph. Check your answer. For this one, it appears to be at -4. There's only one because it is the vertex of the graph. So you check by plugging it back into the original equation and seeing if it ends up being equal to 0. And it does, so you know you've chosen your zero correctly. Notice that if a parabola has only one zero, the zero is the x-coordinate of the vertex. Find the zeros of the quadratic function from its graph. Check your answer. The graph does not cross the x-axis, so there are no zeros of this function. Find the zeros of the quadratic function from its graph. Check your answer. Here's one for you to try and then you can check back. The graph does not cross the x-axis, so there are no zeros of this function. Find the zeros of the quadratic function from its graph. Check your answer. This one is for you to try and you can check back to the slideshow for the answer. The zero appears to be at 3, and when you plug it back into the original equation, you end up getting a result of 0, so you know you've picked your zero correctly. A vertical line that divides a parabola into two symmetrical halves is the axis of symmetry. The axis of symmetry always passes through the vertex of the parabola. You can use the zeros to find the axis of symmetry. If the function has 1, 0, use the x-coordinate of the vertex to find the axis of symmetry. So if the vertex is at 3, 0, then the axis of symmetry would be x equals 3. If there are two zeros, then you can use the average of the two zeros to find the axis of symmetry, since it will be directly in the middle of the two. So if we add -4 and 0 as the zeros, and we add them together and divide by 2 to find their average, it would be -2. So the axis of symmetry would be x equals -2. Find the axis of symmetry of each parabola. For A, you're going to identify the x-coordinate of the vertex, which is -1, 0, and write out the equation for the axis of symmetry, x equals -1. For B, you have to find the average of the two zeros since it touches the x-axis twice. They are 1 and 4, so we add them together and divide by 2 and get 2.5. Then we write the axis of symmetry as x equals 2.5. Find the axis of symmetry of each parabola. These two are for you to try and then you can check back for your answer. For A, you have to identify the x-coordinate of the vertex, which is -3, 0, and write it out as the axis of symmetry equation x equals -3. For B, there were two zeros, so you have to find the average by adding the two zeros together, -2 plus 4, and dividing by 2, which would be 1. And then you write the axis of symmetry equation as x equals 1. If a function has no zeros or they are difficult to identify from the graph, you can use a formula to find the axis of symmetry. The formula works for all quadratic functions. So for the quadratic function y equals ax squared plus bx plus c, the axis of symmetry is the vertical line, x equals -1 times b divided by 2a. So for example, if we had the equation y equals 2x squared plus 4x plus 5, we would use our axis of symmetry equation, x equals -1 times b divided by 2a, and we would plug in 4 for b and 2 for a. So we would have -1 times 4 divided by 2 times 2, which would end up being -1. So the axis of symmetry equation would be written as x equals -1. Find the axis of symmetry of the graph y equals negative 3x squared plus 10x plus 9. Step 1, you need to find the values of a and b so that we can plug them into the formula. The value of a is negative 3 and the value of b is 10. Step 2, we're going to use the formula x equals negative 1 times b divided by 2a, plugging in 10 for b and negative 3 for a. We would have negative 1 times 10 divided by 2 times negative 3, which would end up being 5/3. So we would write the equation for the axis of symmetry as x equals 5/3. Find the axis of symmetry of the graph y equals 2x squared plus x plus 3. This one's for you to try, and then you can check back for your answer. Step 1, find the values of a and b. So y equals 2x squared plus 1x plus 3, a is 2, and b is 1. Step 2, you're going to use the formula x equals negative 1 times b divided by 2a, plugging in 1 for b and 2 for a, and then reducing to get negative 1/4. So you would write the equation as x equals negative 1/4. Once you've found the axis of symmetry, you can use it to identify the vertex. So finding the vertex of a parabola, step 1, to find the x-coordinate of the vertex, find the axis of symmetry by using zeros or the formula. Step 2, to find the corresponding y-coordinate, substitute the x-coordinate of the vertex into the function. And then step 3, write the vertex as an ordered pair. So to find the vertex of y equals 0.25x squared plus 2x plus 3, we're going to find the x-coordinate of the vertex by taking the average of the two zeros, which are negative 6 and negative 2, and we end up with negative 4. So negative 4 is going to be the x value of our vertex. Now we have to find the corresponding y-coordinate. So we plug in negative 4 into the original equation for x and solve for y, and we end up with negative 1. So the value of the ordered pair of our vertex is negative 4, negative 1. Find the vertex of y equals negative 3x squared plus 6x minus 7. So step 1, we're going to find the x-coordinate of the vertex. We're going to do this using the equation since a graph wasn't given. So we identify a and b. A is negative 3 and b is 6. We're going to plug it into our axis of symmetry equation, x equals negative 1 times b divided by 2 times a. So we substitute in 6 for b and negative 3 for a, and then reduce and end up with 1. That will be the x value of our vertex. Then we're going to find the y value by plugging the x value that we got, which was 1, back in for x in the original equation and solving for y. So we end up with negative 4. And then we write it as an ordered pair, 1, negative 4 as the vertex. Find the vertex of y equals x squared minus 4x minus 10. This one's for you to try, and then you can check back for your answer. Since there was not a graph given, to find the x-coordinate of the vertex, we're going to use our axis of symmetry equation. So we're identifying a and b. A is 1, b is negative 4, and plugging it into the axis of symmetry equation, x equals negative 1 times b divided by 2a. So we're substituting in negative 4 for b, and then 1 for a, and then reducing, and we get 2. So the x-coordinate of the vertex is going to find the y-coordinate, we have to plug the value of 2 back into the original equation and solve for y. So we end up with y equaling negative 14. So we would write that as an ordered pair for the vertex 2, negative 14. The graph of f of x equals negative 0.06x squared plus 0.6x plus 10.26 can be used to model the height in meters of an arch support for a bridge, where the x-axis represents the water level and the x represents the horizontal distance in meters from where the arch support enters the water. Can a sailboat that's 14 meters tall pass under the bridge? Explain. The vertex represents the highest point of the arch. Step 1 is to find the x-coordinate. So we're going to use, since we don't have a graph, the axis of symmetry equation. We're going to identify a and b. So a is negative 0.06 and b is 0.6. And we're going to plug them into the equation x equals negative 1 times b divided by 2a. So we're going to substitute in 0.6 for b and negative 0.06 for a and reduce, and we end up with 5. So the x-coordinate for the vertex is 5, and then we're going to find the y-coordinate by plugging 5 back in for x to the original equation and solving for y. We end up with 11.76. Since the height of each support is 11.76 meters maximum, the sailboat cannot pass under the bridge. The height of a small rise in a roller coaster track is modeled by f of x equals negative 0.07x squared plus 0.42x plus 6.37, where x is the distance in feet from a supported pole at the ground level. Find the greatest height of the rise. This one is for you to try on your own, and then you can check back for your answer. Step 1 would be to find the x-coordinate. So you're going to do that by plugging it into the axis of symmetry equation. So you need to identify A and B. A is negative 0.07 and B is 0.42. And we're going to plug it into x equals negative 1 times B divided by 2A. So we're going to substitute in 0.42 for B and then negative 0.07 for A. And when we read 3. To find the y-coordinate, we're going to plug 3 back into the original equation and solve for y. And we end up with 7 feet. So the height of the rise is 7 feet.